All right. So I'm Theo. I work on ZK Passport. So we are a solution around ZK identity. So today, online identity verification is a rather cumbersome process. So generally, you just end up sending your whole passport or ID in a KYC provider, and you hope for the best in the sense that you hope that it's all secure. They're gonna keep your data safe, and it's not gonna leak. Otherwise, you could have identity theft and other kind of issues from that. This is not the best solution, so we can do better. So the idea is that we use physical IDs, such as those passports. So this is a real one, or ID cards. And with ZK, we're able to actually leverage that. So the way we do this is that in those documents, you have like a chip, so an electronic chip that's readable with NFC, with a phone. So any phone can read this. So this standard is actually widely supported across the world. Over 150 countries actually supports it. So about maybe 1 or 2 billion documents. So that's a lot of people. And with this ZK and all these building blocks, we're able to build a pretty good solution. Now to explain how it works, I'm going to do a little demo. Show it. So this is, for example, an integration we did for DEF CON ticketing. So a discount that was given to only Southeast Asian citizens. So with our app, so this is the process you would do for any kind of like identity verification with our app. So you have the app. First, you open the passport on the detail page. So you scan the 2 line at the bottom. This contains the necessary information to derive the decryption key, so that afterwards you can communicate with the chip, read the data, including the photo and other information such as name, date of birth, or country. From this, you're able to derive all kinds of details, and in this case, we care about the country. So when you click on continue, it shows up a QR code, you scan it with the app, it will trigger the process. Essentially, it will ask for my country. So it has all the data. All this is done locally. Nothing is sent anywhere else. I accept. So this generates the proof, which at the end is sent back to the website, which will be able to verify it and only learns that I'm from a given country. In this case, I'm from France, so I'm not going to be able to claim the discount. But if you were from Southeast Asia, that would work. So this is the general idea. Now, for more detail of the process, the way we're able to generate those proofs, so this is the overall process, but I'm going to go over an overview. So the idea is this idea of trust chain. So for people that are familiar with SSL certificates, that will ring bells. But essentially, the country that issued the passport signed the data. So this is an intermediary certificate that signed the data, which is signed by the root certificate, and this is our source of trust. So as long as you trust the state, then you're sure that that passport is valid. You do that verification of those signatures within the ZK circuit, within the ZK proof, and you're able to attest that it's a valid and authentic document. And you can use the data that was signed to derive all kinds of information, as I mentioned before. We also use a nullifier to be able to generate proof of uniqueness. We can leverage for proof of personhood. Benchmark-wise, so we tried out verifying passport using SP1 during the residency. So the sample was done with this passport, actually, French passport. So the main operation done at 2048 bits RSA signature with 3 SHA-256 for the data integrity check and some array manipulations. All this take about 1.8 million cycles. That was what's done on this computer, a MacBook Pro M1 Max, and this took about 2 minutes to generate with up to 13 gig of RAM consumed. So this was done with the latest precompile for RSA. So it's a pretty good improvement to the previous performance, but still for now on the client side, such as a mobile, it's a bit limited for us. So right now our core stack is Noir using Honk as the proving scheme. And equivalently on an iPhone 16 Pro, the same kind of operations is about 9 seconds with up to 2 gig of RAM consumed. So custom circuits or ZKDSL for now are like still a bit better for client-side proving, but ZKVM are going probably in the right direction at the moment. The next step for us will be to finish our core SDK so everyone can use our app to generate proof of identity directly from their web app. with the React SDK coming right after it. So you can just include a component and you're ready to go. And we take care of the whole process. Finish development of the new app that will support Android and not just iOS, because this is only iOS for now. And work on our wallet for Aztec, which is a privacy preserving layer 2 for Ethereum, which will integrate ZK Passport natively, so you have like compliance and privacy at the same time at the wallet level. And that's it. You can follow us on GitHub and Twitter if you're interested to know more.
Thank you so much, Theo.